Welcome to week one of our revision. In this video, we're looking at computer systems and the CPU, which is paper 1, topic 1.1. Okay, so find sheet 1, which has been given to you in lesson. This is the sheet you should have in front of you with a pen ready to answer and make notes. Okay, start off with, what is a computer system? This is right back to the very beginning. A computer system is something that can take inputs, process them, and create outputs. And it uses both hardware and software. There's the diagram we've got there. Input, process, and it creates an output over here. And you've also got storage to store your programs so you don't lose them. Input, process, output, hardware and software. There are different types of computer systems that we talked about in the very beginning. Desktop PCs, tablets, notebooks, games consoles, servers, smartphones, and one specific type of computer system called an embedded device. So this is an important one because they could specifically ask you about this. An embedded device is a different version of a computer system. It is a computer system that is built into another device. For example, a microwave, smart TV, petrol pump, anything with a computer built into it. Examples there you can see include electronic calculators, GPS, digital watches, central heating systems. Anything with a computer built into another device is an example of an embedded system. What are the main features? What makes it different from a normal computer system? They are not general purpose. They normally have a single main purpose or a limited number of functions. For example, cooking your food, calculating numbers, monitoring fitness. They are not designed to be a full usable computer system. You can't do your homework on the microwave, for example. And embedded systems are not usually programmable by the user. A user can't change the code on it. It's done by the manufacturer only. But you can get updates sometimes, like updating your sat nav or updating your watch with new software. What are the main advantages of using an embedded system? Well, because they have got a limited number of functions, they are cheaper to design and build. They require less power. Some even run on batteries. Things like smartwatches and things run on batteries. And they don't need much processing power, so you can use cheaper, less powerful processors in making them. Cheaper, less powerful processors because they don't need as much power. So now I want you to complete this section of your revision sheet. Pause the video, write down what you can remember, and then we're going to add to it with the answers in a second. Okay, ideally, with your purple pen, add to your answer. Make sure you've got these correct definitions. Computer system can take inputs, process, and create outputs, hardware and software. A computer is built into another device, an embedded system. Microwave, washing machine, smart nav, sat nav, smart TV, sat nav. And the benefits: limited number of functions, require less power, can be built using cheaper, less powerful processors. Correct, pause, and make sure you've got that before you move on. Okay, so now we've looked at types of computer systems, we are looking at one of the most important parts of the computer, the CPU, the process part in the middle of the computer system. What is the purpose of the CPU? What is its reason? To process data and instructions by carrying out the fetch, decode, execute cycle. Processes data and instructions by carrying out the FD cycle. Inside the CPU, there are different parts. These are the parts that you need to know about for the exam. Control unit, ALU, arithmetic logic unit, cache, and the registers. And the buses is good to know as well. So what do they do? The control unit controls the flow of data, how the data moves around the CPU. It's also in overall control of the CPU. So like the director. And it also decodes the instructions during the FDE cycle. The ALU, the arithmetic logic unit, carries out all the arithmetic and logic operations, things like adding, comparing numbers, etc. The cache is quick access memory and it's inside the CPU and it stores regularly used data and instructions. It is quicker than going all the way to main memory. It's quicker to access. Registers are super quick memory. They are the fastest memory in the computer system, and they store tiny bits of data, things like a single address or a single value. And finally, buses. In the real world, buses transport people. In the CPU, buses are used to transport data around the CPU, binary information. Okay, now complete this section here in the middle of your sheet. When you've got your answers down, check on the next part to see if you've got anything missing. Okay, checking your answers. Purpose of the CPU: process data and instructions by carrying out the fetch, decode, execute cycle. Control unit controls the flow of data in overall control of the CPU. ALU carries out the arithmetic and logic operations. Cache is quick access memory inside the CPU and it stores regularly used data and instructions. And the buses transport the data around the CPU. Purple pen and correct your answers before moving on. Final section today. We talked about registers in the CPU. There are 4 registers that you need to know. And just to remind yourself, what are registers again? They are super quick memory, they are the fastest memory, and they store tiny bits of data, a single number, a single address in each register. And there are 4 that you need to know for GCSE. We have the program counter. The program counter register holds the memory address of the next instruction that's going to be fetched, the next instruction. The accumulator, or ACC, stores the results of any calculations that have been carried out by the ALU. The ALU does the instructions, or the calculations, and the accumulator, the register, stores the results. The MAR, or memory address register, holds the memory address about to be used. It's the one that's about to be fetched from memory. And the memory data register holds data or instructions being transferred to and from memory. Any data that's coming from memory or going to memory goes through the MDR. It's like a buffer, a register that stores data being transferred to and from memory. Okay, checking on your sheet, filling in the gaps. What are registers? Super quick memory, store tiny bits of data. Program counter holds the memory address of the next instruction. Accumulator stores the results of any calculations in the ALU. Memory address register holds the memory address about to be used. And memory data register holds data or instructions being transferred to and from memory. Checking your answers before finishing the sheet. Okay, finish the sheet. Your final task for this week then, the second part of the homework, is to go to Learn Cumdine, GCSE Computer Science, the revision section, and complete revision quiz 1. For each question, answer it, click the check button to make sure you've got it right, and if you haven't, correct your answer by clicking try again. You should be getting 100% correct by the end of this quiz. That is the score I'm looking for after you've checked and corrected your questions. I'll be checking in lesson and any lunchtime catch up for uncompleted work. Good luck.